Hi everyone, welcome back to another video on problem solving in general and the study session. So today I'm going to go over a problem with you together. I haven't seen this problem before and I hope you haven't seen it either. So let's get started on solving this problem. So a ferry is initially 10 meters from the edge of the dock. It has been pulled into the dock by a rope. The rope is attached to the ferry at a point 2.5 meters below the place where it is pulled over the edge of the dock, as shown in the diagram. The question asks, if the winch pulls is 1 meter of rope, how far does the ferry move towards the dock? Okay, so let's draw a quick sketch of the diagram and then analyze the forces involved in this question. So as you can see, this is, instead of drawing boat, let's just say this object is the boat. We have, this is the water, this is the wall. Oh, I should draw it like this. And okay, so the rope is connected from the point here to the edge of the dock as such, and essentially the rope is pulled inwards. We know that the height is 2.5 meters and that the distance is 10 meters from the boat to the dock. We're asked, how far does the ferry move towards dock? So we know that the winch pulls in 1 meter of the slope. So let's say this is L, right? So L reduces by 1 meter. This is the new scenario here. So the boat is closer to the dock, and the distance between the edge of the dock to the object is L minus 1 meters, and the distance, that vertical distance, is still 2.5 meters because the boat is still floating in the water. So now we're asked, how far does the ferry move? Well, in order to find the distance that the boat has moved, we need to subtract 10 meters from the current distance from the new position of the boat to the edge of the dock. So this new distance, let's call it d, is, according to Pythagoras' theorem, d is equal to square root of L minus 1 squared minus 2.5 squared. And we know from the original scenario where the boat was not yet pulled, the scenario is, according to Pythagoras, L squared is equal to 2.5 squared plus 100, not 100, it's 10 squared, sorry, 10 squared. So from this, what we can say is we can use a calculator to work out what L is. So I'm just gonna grab a calculator. So L would be the square root of 2.5 squared plus 10 squared, which is just 100, and that is about 10.3078-ish. And so D would be approximately equal to, it's a square root of L minus 1, so I'll just say answer minus 1 squared. Wait, okay, so square root of L, which is the answer, minus 1 squared minus 2.5 squared. And this gives D about 8.9657, blah, blah, blah. And then you subtract D from L. So 10.3078 minus the answer. So this gives the distance. How far does the ferry move towards the dock? Well, the distance would be L minus D, which is about 1.34 meters. Let's check the answer of the question. Checking the answer, we don't have 1.34 meters, so there is something wrong in this question that we haven't yet discussed. There's no such answer as 1.34 amongst the 3 or 4 answer choices in the question, so we have to redo the question again. So let's reread the question very carefully. It says, a ferry is initially 10 meters from the edge of the dock, is being pulled into the dock by a rope. The rope is attached to the ferry at a point 2.5 meters below the place where it is pulled over the edge of the dock, as shown in the diagram. If the winch pulls in 1 meter of rope, how far does the ferry move towards the dock? Well, we have the situation. Scenario 1, it is entirely correct. In scenario 2, I think it is correct too. So it now really depends on the calculations and check whether we've calculated the values correctly. So we know that L squared is 2.5 squared plus 10 squared, so 2.5 squared plus 10 squared is 106.25, and taking the square root of that, we get 10.3078. I think that is correct. Just marking it correct. And then now we need to find D. Well, we know that the vertical height did not change, so we can essentially say, well, we know L, we just need to do L minus 1 squared. So that gives the hypotenuse of this triangle, and then minus the 2.5 squared. This gives an answer of 80.38, and then because the answer we get is D squared, we have to take the square root of that number. So square rooting the answer, we get 8.9657. And 10.3078 minus 8.9657, we get 1.34. So it seems that the boat moves 1.34 meters inwards, which is not captured in the answer choices. Let's think about the whole problem once again. Is there a force element? Is it a purely maths question, or is it physics? Let's think about it. So prior to the pull, we have this configuration where the L is the hypotenuse, or the distance between the boat and the dock, as shown. 10 meters and 2.5 meters. That's correct. Let's reread the question again. So it says, if the winch pulls in 1 meter of rope, how far does the ferry move towards the dock? So it pulls in 1 meter of the if it pulls in 1 meter, then in the second scenario, it's the second diagram where the boat has moved closer to the dock, the distance between the boat and the edge of the dock would be the original distance minus 1 because it's pulled 1 meter closer to the dock. So I think it should be correct. I think it should be correct. Let's, you know what? Let's use a different calculator because I think my method of solving this problem is correct. Let's use a different calculator. So we want to find L. L is just the square root of 2.5 squared plus 100. That gives 10.3078-ish. Yes, that's correct. Now what we need to do is take the square root of L minus 1, which is the answer, minus 1 squared minus 2.5 squared. This gives an answer of 8.96. If you take the difference, I think it's still 1.34, but it's not captured in the answer, so I'm not sure why that is the case, but it is very very strange. Perhaps I was wondering if you, instead of taking 10.30878, if you've taken 10.3 as the answer and then use 10.3 in the subsequent calculations, you might get the answer that the question wants. So let's say L is equal to 10.3, then D in this case would be, I'll edit the answer right now. So 10.3, never mind, do 10.3 and then that. So D would be 8.96, about that. Then we go 10.3 minus 8.96, you get 1.34, still 1.34. So in this scenario, it's really difficult to get an accurate answer. I'm thinking perhaps if you take L as 10.3, if you take L as 10.3 and plug it into this formula, you would get something about 8.96, which is approximately equal to 9 in this case. But yeah, I think that's the answer to the question at 1.34 meters.